Hello everyone, my name is Erkin Atay Toka. Today me and my partner Taylan Cengiz are going to present you our EE214 electronic or EE214 end-term project. The name of the project is Analog Baseband Tunable Receiver, and this project consists of three parts: the transmit unit, the receiver unit, and the speaker unit. I am going to present you the transmit unit and the receiver unit, and the rest is my friend Taylan Cengiz will present it to you. So in this transmit unit, we were asked to generate frequencies, sinusoidal waves with frequencies from 1 kHz to 15 kHz, except the 4 kHz and its multipliers. So as a solution, we think we could generate 4 kHz and we could generate 1 kHz square wave and 2 kHz square wave and sum them up so that we don't get 4 kHz frequencies in our transmitter. As you know, a square wave with 1 kHz frequency consists of odd frequencies sums. So this will work. So let me show you the FFT of our 1 kHz generator. And this is it. As you can see, we are generating from 1 kHz, 3 kHz, 5 kHz and so on, and the even ones are not here. So we construct another generator, 2 kHz generator, to obtain the even ones which are two multiples of the even ones, and this is it here. And the FFT of it you can see here: the 2 kHz, the 6 kHz, the 10 kHz, and we are generating the frequency that we need. So when we sum up, we will get all the things we want. And here is our just show it, the summing amplifier here. So let's go to its output and see the FFT, and here. So as you can see, we sum all the signals, and this is the FFT we wanted. As you can see, we are generating 1 kHz, 2, 3, we don't generate 4, we generate 5, 6, 7, we don't generate 8, and it goes on like this. So this is pretty much it. As you can see, we generate all the wanted frequencies, and we didn't generate the other ones, the multiples of the 4s. So we can continue with our receiver unit. In the receiver unit, they ask to filter a specific frequency that we generate in the receiver part. So for a solution, we use a bandpass filter with 1 kilo ohm with a potentiometer. As you can see here, we use 1 nanofarad capacitors and 680 kilo ohm resistors and 10 kilo ohm resistor, and we use only one pot to filter it. By changing the resistance value of these pots, potentiometers, we will filter the necessary frequency actually. So let us see our output of the filter. Let me show you that. This is our output of the filter. Okay, for a filter to work, to filter a certain frequency, we need 10 decibels difference between the other frequencies. So let us see. In this part, we are filtering 6 kHz. Okay, so let us see what is the decibel difference. We are using Y cursors. As you can see, the filtered frequency is at 1.8 decibels, and the biggest accepted is in the minus 7.8 decibels. The difference is like 15 decibels. This means this filter works properly. So let me show you by changing the potentiometer here, the shift in the oscilloscope. I change it, show the oscilloscope. This is the oscilloscope. Now look, I am filtering the 7 kHz, which is in the minus 1.8 decibels, and the biggest one is the minus 11 decibels. The difference is 10 decibels again, so it shows it's a good filter. So let me show you another one. Actually, let me filter the 5 kHz now. You see, it's changing when I play with the potentiometer. It stopped here. Okay. I will show you. Now we are filtering 2 kilohertz. Okay. Now we are filtering. Let me change. Now we are filtering 1 kilohertz. As you can see, we can filter any frequency we want by changing our potentiometers. So our filters work efficiently and properly. This is all about it. The next part, my friend Taylan Cengiz will present to you.
Hello everyone, my name is Taylan Cengiz. My friend Erkan Taytoka presented to you receiver and transmitter unit. End of the transmitter unit, we obtain a sinusoidal waveform with a specific frequency. Now we play in speaker unit this frequency with this speaker 0.5 watts and it's 8 ohm. We use 3 op amps. It's non-inverting amplifiers and inverting amplifiers, and also we use 100 nanofarad capacitor to decrease this AC offset. And also we use 100 kilo ohm trim pot to use change sinusoidal waveform amplitude.
So why did we need to change the amplitude?
Okay, because the waveform obtained in receiver unit amplitude is too small, and to play this waveform in speaker unit we amplify it, and we can use this trim pot. If we change trim pot resistor, sinusoidal waveform amplitude change and volume change. Let's play this speaker unit. This beautiful sound for you. Okay. Sounds.
Let's play with the amplitude a little bit. Yeah, you can hear it better.
Yes. If we change, amplitude is changed and volume changed.
It's changing, yes.
Yes.
Okay.
Okay, this end of the EE214 term project demonstration. Thank you for listening.